Well, thank you for having me. I'm Owen. I'm going to give you a brief history about sandstone mining in Yorkshire and then talk to you about how, as geologists, we can apply our knowledge to put together a remediation scheme for these mine workings to prevent sinkholes. So here we are. When people talk about geologists, they generally think of guys or girls jumping out of helicopters looking for shiny things. This is not that. I do spend most of my time in a field in Yorkshire, but stick with me, it's just as interesting. So when you think about mining in the north of England, you may get images like this, coal mining, which would be right. It is a large industry, it has history all over the region, but it's not the whole story. There's more to it than that. Sandstone mining is often quoted as the forgotten industry of Yorkshire, and it's all to do with the geology. So here we have a geological map of West Yorkshire. We've got Leeds and Bradford up there, and across there we've got these two grey bands. These are the lower Pennine coal measures. Below it, we've got the Millstone Grit. And as you'd expect, in the lower Pennine coal measures, we have a lot of coal, and hence the coal mines. But as you can see from the strat column, we also have these lenses of sandstone. Up here, we have the Elland flag sandstone, soft bed flags, and the name of these sandstones reflect the nature. So they're quite flaggy. It's a good quality sand and really useful for building. So if you've ever been to Yorkshire, you'll see that a lot of the buildings are made from sandstone. And so that is a reason for it being quite targeted during, well, pre-war, basically, when sandstone was a viable building material. And on this map, you can see the blue dots. They represent sandstone mines. And that ranges from surface quarries down to underground mining where they've accessed via shaft. So why is this a problem? Well, these are images just to give you an idea of the sandstone mining. It can range from a man with a flat cap and a pickaxe to adits and such as that. So the problem, sinkholes. Well, we don't want this to happen, and we've got to then apply our knowledge to stop this from happening. And so this is where we come in. I think the best way to explain how we solve the problem is with an example. So this example here, this is a site in Bradford. It's a field, and a housing developer wants to put on 60 plots. But unfortunately, during the early stage site investigation, they've identified Elland flag sandstone mine workings at a depth of around 20 metres below ground level. And so we had to put together a strategy to treat these mine workings to prevent any subsidence from occurring and make these houses safe. So this is what I came up with. This is a drill layout plan. Each one of those blue circles represents a borehole. And into that borehole, we then can inject grout into the mine workings. The grout will then stabilise the ground and eliminate the chance of subsidence. So, in come the drillers. So this is Ryan on the right, and what he's doing there, he's drilling these boreholes. That's a borehole that he's already drilled, and he's logging what he's finding as he goes. And on a day-to-day basis, he's producing drill logs, which he's passing to me. And these aren't in-depth drill logs. All he is telling me is he hitting sandstone, mudstone, solid rock, or is he hitting something else? And what we're finding on this site, he hit a lot of broken ground, he was calling it, and I asked him what this meant, and what it meant is he's going through solid competent rock, and then suddenly he's getting low resistance on his drill rods, and he's losing some of his flush, his air flush that he's returned from the top, and he's saying it's loose ground. And so from that, I can then interpret what he's hitting. And I interpret that as being possibly backfilled mine workings. A miner might have chucked some rubbish material back there, or migrated mine workings, it's been left open and collapsed, and such as. So when he's done the whole site, this is what I can produce. This is an as-built model. I respect it's quite confusing, but I'll try and summarise. So these red boreholes here, they represent holes where he's drilled and he's hit solid rock all the way to the level of the mine workings, about 25 metres below ground level he's gone to. And he's hit nothing but sandstone or mudstone. No evidence of mine workings. Whereas the green boreholes, these represent the broken ground that I was just speaking about. And then the blue boreholes as well, these represent voiding that he's encountered. So I interpret that as being open mine workings that have just been left unremediated and potentially may cause subsidence. So from this, I could put together a very rough model. So on this site, we look like we've got this large area of unworked sandstone, but then we've got these problem areas here of workings which may cause subsidence. And we can use this then to target our grouting and try and treat the mine workings to stop all movement. And this is where the grouters come in. So, grout is just a mix of ash, which is a byproduct of burning coal in the coal power stations. We mix that with cement, and then we add water and pump it across site. So that's what that there is going on there. So that telehandler, that chap there, is dropping some ash and cement into that mixer, mixing it with water and pumping it across site and he there is holding the tremie pipe where the liquid grout is coming out the other end. He'll then take that tremie pipe and insert it to the bottom of the borehole, and we'll start to fill the mine workings from the base up until we've filled all void spacing and ideally treated the works. But that's not all, because once we've treated the works across the grid, we also have the consideration of mine entries. If there's mine workings underground, it makes sense for there to be access to them. And this is what we found on this particular site. So if you look at these 3 holes here on the as-built plan, these are holes that the driller has recorded as soft push from surface. That is to say, he's gone with his drill rig, he started to drill, but he's had no resistance on his drill rod from the surface all the way down to the level of the mine workings. An instant red flag, because it means that someone's tampered with the ground, and most likely it's an entrance into the mine workings because it stops at the level of the mine workings. So it's our duty to investigate this. So this is what I did. I had a dig around, and this is what I found. So this is a mine shaft. Perhaps not what you'd expect. It is just a black circle on the ground. But this is what we often find when we're looking for mine shafts on these sites. Here's another one. Found this one on Wednesday. And these present a huge problem because generally when we get sinkholes, it's often from a shaft that has failed, and we don't want that. So we go and we treat this as well, again with grout, but safety is number 1 in these cases because if a sinkhole forms, it could take personnel or machinery with it, so we need to make sure we're doing things safely. So in this case, we put steel girders across the mine shaft, and then we put the drill rig on top of that, and they drilled from the platform. They drilled to the bottom of the shaft, and then they started to inject grout, but this time under pressure. So before they drilled, they put casing in to create a sealed unit. They injected the grout, and they injected until they reached lithostatic pressure in that depth. And then once they've reached lithostatic pressure, they'll stop pumping, make sure that we hold that pressure to show that the grout isn't escaping it. And once it's held for 5 minutes, we then consider that to be treated. And ideally, we'll have a little bulb of grout at the bottom. And then we'll repeat that process in 1.5 metre lifts. So we'll lift the casing up 1.5 metres, start injecting grout again. When we reach that pressure, hold it, and then eventually we'll create a column of grout in that mine shaft with all these bulbs. And we'll do it for these cases, we do it 3 times in every mine shaft because of the size of them. And then once we've finished that, we then consider that to be treated and safe. But then just finally, we then put a shaft cap on top as well. So this is a reinforced steel cap, and that's just in case it should ever go again still, the substance won't affect the surface because we have a cap to prevent any failure. So for this site, just to summarise what we did on this particular site, we ended up drilling 895 boreholes, and into which we put over 12,000 tonnes of grout and an additional 4,500 tonnes of gravel, which is the equivalent to filling about 1/10 of the Albert Hall, which shows you how extensive these mine workings can be. But perhaps more applicable to this crowd, that's about 100,000 kegs of beer that we put in the ground. So what I wanted to get across with this talk is history of mining in Yorkshire has created almost a whole new industry in remediation. So we've kind of gone from the exploitation of these minerals to the remediation of them. And UK geologists still play a very key role in developing sites or all aspects of engineering, and that's where we need to have more geologists as well. Thank you very much. I'd like to answer questions.